Okay, so today we're going to look over a couple examples of things called mixture problems. So, mixture problems. And what these are types of problems where you're given two bottles of different percent strength liquids, and your goal is to hit a target percent strength. So you're going to have to mix the two different bottles together at a certain ratio in order to get what you want. So what we're going to say here for our first example, we're going to do probably 2 or 3 of these. Let's say Sam has a bottle of 20% strength acid and a bottle of 50% strength acid. Say they want eight gallons of, say, 34% strength acid. So how much of each bottle should they use? So what we're going to do here is we're going to draw a little picture of the setup. So usually I like to just we'll draw little things like this to represent the bottles. So we got our bottle of 20% strength. We got our bottle of 50% strength. And we're trying to get a mixture of 34% strength. And below it, I'm going to write the amount of each of these. So we want 8 gallons of the 34% strength. Now, we don't know how much 20% strength to use, so we're going to just put an X there. And the 50% strength, I don't know how much of that to use either, so we're going to put a Y there for a variable representing that. Now, I'm mixing two amounts together, so I have X gallons here and Y gallons there. If I mix X gallons with the Y gallons, I should end up with 8 gallons. So what that means is X plus Y should equal 8. Therefore, we can subtract the X across and get Y equals 8 minus X. And what this will let us do is instead of using the symbol Y here, we can use the symbol 8 minus X there. And then we have less variables to take care of. So now everything's in terms of either numbers or just X. There's not a second variable Y. So to move on, what we're going to do is we're going to take this is going to say 20% of the X gallons is pure acid. This one says 50% of the 8 minus X gallons is pure acid. And this says that 34% of the 8 gallons is pure acid. So we're going to write an equation that lines up the amount of pure acid in the system. So we'll say, put a little line here, 0.20 times X plus 0.50 times 8 minus X will equal 0.34 times 8. And to make the numbers a little easier, like you can solve this through with decimals, but to make the numbers easier, I think if we just multiply the whole equation by 100, we're able to bump the decimal places 2 units over. That'll make all of these just be whole number multiplications. So we can get 20x plus 50 times 8 minus x equals 34 times 8. And so now we'll look at this. So we get 20x plus, we want to do 50 times 8. So let's get some little scratch work here. Oops, that's not 58. 50 times 8. 8 times 0 is 0. 8 times 5 is 40. So that's 400 minus 50x equals 34 times 8. Let's see, that's 32. And then 8 times 3 is 24. 24 plus 3 is 27. So we get 272. So now, 20x take away 50x is negative 30x. That equals, we're going to subtract the 400 across. So we got basically, let's see here, 272 plus 28, that'll be 300. So 300 plus another 100 is 400, so this should be negative 128. I believe that's right. So then we'll say x is 128 divided by 30. So I use a quick little calculator to figure out what that is. And we get 4.27 gallons, basically. And for this, I gotta say, which type is that? Because, say, well, is that the 20% or is that the 50% bottle? Well, we're calling that X. So X is what we used for the 20%. So this is going to say 4.27 gallons of 20% is what we want to use. For the Y was the total 8 gallons we were trying to get to, minus the X. So Y was 8 minus X. So Y is 8 minus 4.27. So we'll just use our little calculator for that. And we get, this is 3.73 gallons. And since the other one here was 20%, this is going to be the amount of 50%. So I got to make sure to label which one's which, because if I don't say, well, this is 20% and that's 50%, then I'm not sure which amount goes with which. So this will give us kind of the ratio that you mix the two bottles together to hit your target mixture. So we're going to look at kind of two more of these cases. So look at a second example. Let's say how much 60% strength acid should be mixed to 4 liters of 20% strength acid to get a 41% strength mixture. Okay. So we'll draw our little picture again. That plus that equals this. We'll say, okay, here's our 60% strength. We're going to be adding that to 20% strength. And we want to end up with a 41% strength. We have 4 liters of the 20% strength. We don't know how many liters of the 60% strength we have. But if I'm mixing X liters to 4 liters, X liters plus 4 liters would be the total amount of liters over here. So I could have written Y and thought it through, but in this one, unlike the previous example, it's a little bit easier to see. You're mixing two things together, X liters here, 4 liters here, so the total amount from the mix would be the X plus 4. So we're going to get our equation and say, all right, well, 60% of these X liters is acid. 20% of these 4 liters is acid. And then 41% of these X plus 4 liters is acid. I'm going to do a little like multiply everybody by 100, so I can just bump these decimal places 2 units over to make the numbers a little bit easier to think about. So I have 60x plus 20 times 4 is 41 times x plus 4. So we'll get 60x plus, that'll be 80, equals 41x plus, let's see, 41 times 4. See, 4 times 1 is 4, 4 times 4 is 16. Okay. So then what we'll do is we'll subtract the 41x's across. And we'll subtract the 80 across. So 60, take away 41, that should be 19. And then that's going to equal 164, take away 80, it should be 84. So I think x is 84/19. So let's see what that is. 84 divided by 19 is 4.42 liters. So we'll say, all right, 4.42 liters is how much we mix of the 60% strength. On this one, I guess technically I don't need to label which percent strength it is, because in the previous one we had 2 unknown bottles, so you're mixing some percentage of this and some percentage of that. In this problem, you're only adding 60% to the 4 liters of the 20%, so you're only adding one thing, so it's kind of the way the problem's set up. This has to be 60% solution. But just to be clear, we can put a little 60% up there. Okay, so that solves that one. And then the final one we're going to look at is, we'll say for this example, say how much water should you add to 6 gallons of a 30% strength solution. We'll say acid again, I guess, to dilute it to say 11% strength. So we have a higher percent strength. We're trying to dilute it with water to end up with a lower percent strength. So again, we'll draw our little bins here. So we got 30% strength. We're going to mix water with it. Water is 0% strength. And then we're going to end up with an 11% strength. We know we got 6 gallons of the 30% strength. We're asking how many gallons, so x the unknown gallons of 0% strength. 6 gallons plus x gallons says the total amount will be 6 plus x over here. So now we say, okay, 30% of those 6 gallons is pure acid. 0% of those x gallons is pure acid. And then 11% of those 6 plus x gallons is pure acid. So that we're going to equate how much pure acid is in the system. This I'll do the little multiply by 100. That'll just scoot our decimal places over. On 0, when you scoot it over, it's still 0. So we got basically 30 times 6 plus 0 equals 11 times 6 plus x. So that'll be 180 plus nothing goes away, equals 66 plus 6x. We'll subtract the 66 across. So 180 take away 66. See, 180 take away 6 would be 100, or 60 would be 120. Take away another 6, that would be 114. Equals 6x. And then we divide the 6 across. That'll equal our x. So we will say, all right, what is 114 divided by 6? And that will be 19. So we'll say 19 gallons. And in this case, that'll be of water. So we have to add quite a few gallons to dilute the 30% strength down to where it's 11% strength. And yeah, that'll do it. So we're going to stop there for mixture problems, and we'll do a couple extra in the next video.